Hello, hi. So today I will be sharing with you the rigging process of a delta robot like in this animation. So let's get started. As you can see, I have modeled this robot in Blender. Just kidding, I have downloaded from ABB website but I can't share it with you, so I have made similar simple robot so that you can work along with this video. You can download it from my gumroad page. I have provided link in the description. Go and check it out. I have separated model into mainly 4 categories. First, arms. Second, this end effector. Third, this telescopic arms. And fourth is a static component like motors and platform. Let's rig in this order. First, arm. Add armature, go to edit mode and rename that bone as a base. Add a new bone, arrange it. Change the visibility of bones in front and display them as a stick so that we can clearly see those bones. Extrude new bones like this. Rearrange all the bones as per the joints of mechanism. Change role of all bones in global x-axis. Rear parent this bone and make parent with this bone. Go to pose mode and select this bone and give inverse kinematic constraint. Change chain link to 2. This is motor bone and it will rotate in only one axis. That's why go into inverse kinematic properties and lock x and y axis because it will not take part in IK calculation. Rig of this arm is ready. Parent the objects with its bones. Let's check if it's working. It looks like working. But wait a minute. What is that? Ball joints are roaming in space. But why? Because we didn't take this offset in consideration. See, sometimes our method is right, but approach is wrong. To accommodate that offset, we will add one more bone. Extrude and arrange new bone like this. Clear parent this bone and make a child of this bone. Rename the bone, but make sure you add .l in the end so Blender can symmetrize bone automatically. Rename this as a motor and rename this as a control bone, but don't add .l in the end because we will not symmetrize this bone. Again, IK constraint. This time chain link will be 3. This is an offset bone and it will not move independently. So lock all the axes in IK properties. Now go to edit mode. Select these 3 bones and use symmetrize tool from top menu. Easy peasy. Parents the object with their respective bones. Now select this bone and change the chain link to 1 because it's unnecessary to calculate the motor bone and offset bone motion even though we calculated with the previous IK constraint. Select all the arm bones and change the armature layer. I am using Blender 3.6. If you are using above Blender 4.0, then the layer is transformed into collection. Now duplicate the arm bones and rotate along the z-axis with the value of 120 degrees. Repeat this action. And parent the remaining arm objects respectively to their bones. Now let's rig this end effector. We will just extrude new bones from the control bone like this. Arrange the bones accordingly to the joints. Change role for those bones. Parents the objects. This bone only rotates along y-axis, that's why we will lock x and z-axis moment. This bone will rotate along only z-axis, that's why we will lock x and y-axis moment. Our end effector rig is complete. Let's focus on telescopic arms. We call this mechanism as telescopic arm because it can transfer translation and rotary both motion at the same time using the slider and universal joint. First we will rig this telescopic arm. Add a new bone at the first link position and extrude new bones according to the links. Arrange all the bones as per joints. Recalculate rows of those bones and clear parent this last bone and make parents with this control bone. Use IK constraint for this bone and change chain length to 4. Lock all the axes in IK properties for this bone. Also lock all the axes but change stretch slider from 0 to 1. This bone represents the motor, so it will only rotate in one axis, so we will lock all other axes in IK properties. Balance all the objects. If we rotate the motor bone, all bones are rotating but not this one. To solve this, use copy rotation constraint from the motor bone. Let's check if rig works. It looks like working, but if we see carefully, see at the universal joint, it's not properly aligned as it should be. To solve this, we will extrude new bone from universal joint and arrange in same direction as the slider bone. Scale it down and use lock axis constraint with the slider bone. Change the lock axis from Z to X and tell slider 0 to 1 for this bone. Same we will do for this bone. But this time bone will arrange in opposite direction of the slider bone. Clear parent new bone and make parents with the last bone. Use lock axis constraint with the slider bone and change lock axis from Z to X. Parent those universal joints with these new bones. Let's check it again. See, now it's working as we wanted. We will do the same thing with the other telescopic arm. Change the bone layer. Now this telescopic link is connected to the end effector first link, and this telescopic link is connected with the end effector last link. That's why if end effector rotates, this link will also rotate or vice versa. To make it happen, we will use drivers. Select this end effector bone and go to its rotation axis. In this case, it's y-axis. Right click and select copy as a new driver. Go to motor bone and paste it in its rotational axis. In this case, it's y-axis. Do the same thing for the other end effector bone, but this rotate along z-axis. That's why copy as a new driver from z-axis and paste it in another motor bone in y-axis. Now to visualize our rig better, we will use bone shapes. I already have made some bone shapes to represent base, control and both end effector bones. Now our rig is complete. If you have any problem regarding rig, please ask me in comment section. If you have any video suggestion or rig that you would like me to try or any other method to solve these rigs, please share them as well. Thank you. Bye bye.